Hi students, now we are going to see about the storage structure. This storage structure is coming under the computer system organizations. So under the computer system organizations are having computer system operations, storage structure and direct memory access. So last class we discussed about the computer system operations. Now we are going to discuss about storage structures. Okay. So, if we are receiving the informations from the users and whenever the user wants, the system is going to display the information to the users, like that it's giving the information to the users. So, in between time where the data will be stored, where it will be available, we need some storage space to store these informations. That will be stored by using this storage structure. This storage is organized in the hierarchical manner. Okay, so it is based on this is hierarchically arranged based on the three things, that is speed of the device and the cost of the device and the volatility of the device. Okay, so first of all you see the storage devices are organized in this manner. First the registers, then cache memory, then main memory, solid disk, hard disk, optical disk and magnetic tapes. So these are the storage devices are available we are using for the computer systems. Okay, so first of all we will see according to the speed. It is arranged on the speed, cache and volatility. Okay, so first we will see according to the speed will be increased. The speed will be increased from bottom to top. Okay, so the magnetic tapes and optical disk, these and all the extra additional storage for the system. The hard disk, it will be permanently it will be attached with the systems, and this is also solid disk. It is not mandatory, it is optional one only, but main memory, cache, registers, this will be permanently available in the systems only. Okay, so when we are speaking about the speed, the register speeds will be high compared to the magnetic tapes, optical disk and hard disks. So we are using the hard disk only in the systems. So compared to the hard disk, the speed of the registers will be very high because the CPU is directly contact with the registers only. Okay. So the speed will be increasing from bottom to top. The next we cache wise. The cache, if we are considering, the cache also be increasing from bottom to top. Okay, so the cache of the magnetic tapes and optical disk and this will be less compared to the registers, cache memory and the main memory, because according to the speed the cost of the device also will get increased. Okay, so then only the can assess the system performance will get increase if the speed is increased. Assessing speed will increase, then the system performance also will get increased. So according to that the cost also be increasing. Then if you are talking about the volatility, so you know what is volatility. So the volatility, it depends upon. So volatility means when the power will be there, the data will be stored in the particular device. When the power won't be there, the data will be erased from that device. The data won't be stored permanently when the power is not there. Okay, so that is called, see, volatile means these three memories will come under volatile. So based on the volatility also it is ordered. So when we are talking about the volatility, so this registers and cache memory and main memories are called as the volatile memories, and the remaining hard disk and optical disk and magnetic disks are called as the non-volatile. This solid disk is combined both. It may be volatile also, it may be non-volatile also, it depends upon that. Okay, so first we will see what is volatile and non-volatile. So when power is not there, this registers and cache memory and memory, whatever the data we are entering, that will be available until the power is there in the system. When the power is not there, the data will be erased from the particular devices. that type of memory is called as the volatile memory. So when power is not there also, whatever we are typed, that will be stored permanently in this devices. So whenever we want, we can switch off, and again if you switch on also, the data will be available in the hard disk and optical disk and magnetic tapes. But in these devices, when we switch on the system without saving, the data won't be available in the these are the devices, okay. And solid disk or the electronic disk, some disk may be volatile and some disk may be non-volatile, depends on read write, okay. So this is the way the storage structure will be organized in the hierarchical manner based on the three categories, that is speed, cache and the volatility of the particular device. Okay. So we will see the each storage devices one by one. So first we will discuss about the registers. So registers, I think you already studied in the computer organization, I think. So what is registers? This is the storage devices. It is the less storage devices compared to all other devices in the systems. It may be 8-bit registers or 16-bit registers, okay. So it depends upon the type of the architecture and the type of the processors they may have, okay. According to that, their storage capacity will vary, okay. So but the CPU directly will communicate through the registers only. The CPU wants to perform, for example, yesterday only we discussed about that if we want to add two numbers A plus B, and the data we will receive from the user, the data will be stored somewhere, it may be in the hard disk, but when the CPU wants to perform the operation, it should bring it to the registers. The CPU will contact the registers only when it wants to. See, this is the process 1, P1. The CPU is allotted with the process 1. It wants to execute the process 1. If it wants to execute, it needs the information of A and B. A and B should be available in the registers A. For example, 8, and this is the B value is 7. Okay. So this will be stored in the register A and register B. Then the CPU will take the data from the registers and it will perform the operation of addition. Okay, then it will store again into the another registers, that is C. The result will be stored in the another registers. So this is the way the CPU will use the registers. We already know that CPU is having high speed compared to any other devices in the systems. That speed should be, the devices also should match the CPU speed, then only it can perform the operations without waiting for anything. So the registers will match the speed of the CPU. That's why the end data will be available in the registers to perform the any operations. Then next we will see what is cache memory. Okay. So we know that the CPU is having high speed. So compared to that, every time when the data is if it is available, always we will store it in the hard disk only. These are the non-volatile memories. So permanently it won't be stored in here. Okay, always the data permanently stored in the hard disk only. So every time the CPU cannot communicate with the hard disk. We already know that the speed of the hard disk less compared to these devices. Okay, so if you contact with the hard disk, it will take much time to access the hard disk, because all the this hard disk will have the data like oceans to search. For example, if you are searching the fish, if you are searching the fish in the tank, and if you are searching the fish in the ocean, so which one will take much time? If you are searching in the ocean, it will take much time. It is very difficult to find out. But if you are taking in one tank from there, if you want to catch the fish, it will be easy. So like that only, the CPU wants to take the data from the hard disk. It's very difficult to search and find out the data, and it won't match with the CPU's hard disk won't be matched with the speed of the CPU. It will make much delay. The performance will be reduced. So To avoid that, the data will be transferred from hard disk to the main memory. From main memory, you should go to the, because different levels of caches will be there. Okay, so to increase the speed, each hatch will have different speeds to improve the speed of the performance of the CPU. The different levels of caches will be there. So the data will be bring it to the caches level 1, level 2, level 3, like that. It depends upon the system requirements. Okay, main number of cache levels will be there. So after, whenever the data we need, next we want to perform the operation, that will be, for example, P1 is performing some operation and P2, P3 and P4 are waiting next to perform its task. Then they need some informations. That informations will be there in the informations or data to perform the calculations, because mainly we are using the CPU to perform the calculations only. Okay, so if you want to calculate, we need inputs, or we need some input data. That data will be available in the cache memory, okay, in the different levels. So when this operation is performed, it gets over, then immediately the data whatever need for the process P2, it will be bringing to the register next level. Instead of bring it from the hard disk by searching, it will search everything and will make it ready in the cache memory. So this is the way the cache memory is used here to increase the speed of the CPU. Okay, so important principle, because different levels we are using in the cache memory, and information is copied from slower to faster, because the hard disk is very slower, that's why it is copied to the cache memories for the easy access. And if information used directly from the cache, it will be fast. If it is not present here, then you should bring it from the hard disk to the cache memory. It will take some delay. So during main memory storage devices, we will see in detail about the cache miss, cache hit and all, we will discuss later. Okay, and the cache management importance, design problem, cache size and replacement policy. Okay, so that and all very difficult to manage. For example, which data we have to bring it to the cache memory, and which data we have to again bring it to the hard disk, and how we have to update the caches. If you are making any changes in the hard disk data, that should be reflected in the cache memory also. So that and all, with different mechanisms are there, and replacement policies also be there to handle the cache memory storage. Okay, that and all we will discuss later in detail. Okay, so the next we are going to see about the main memory. So in the volatile, we know that these registers, cache memory and main memories, are called as the volatile memories. In the volatile, the main memory is having the large storage compared to another two devices. Okay, so this CPU can access directly, because it's accessing through the cache and registers, but when the CPU wants to run, the data should be bring it to the main memory, then only the particular process can execute. Whenever it is in hard disk, it is called as the passive process. When it bring it to the main memory only, it is called as the active process. When it's bringing it to the main memory only, it will be active and it will start execution. Okay, so that's why they are telling that directly we are accessing from the main memory, but we are accessing through the register only the data. Okay, but instruction, the data will be in the register, the instructions will move one by one to the registers. Instructions and data will move to the registers from the main memory through the cache memory. Okay, so this main memory is also called as the RAM, that is random access memory. Yesterday also we discussed what is RAM. So whenever the program wants to execute, it should be bring in to the RAM, that is a random access memory or main memory or primary memory. It is also called as the primary memory. So for starting, bootstrap program will be there, then OS will be there, then the OS will create the starting process, that is called init. Init will create n number of process, it will create the user processes also and the system process also according to the requirements. Okay, and So this is the way the main memory. So the process will be created through this only. Here only in main memory only all the process will be created, P1, P2, P3 like that. Then whenever it will get the CPU time, it will go to the CPU, it will execute and it will finish its task by using the registers, because the what task it wants to perform, that will be that instructions and data will be moved to the registers from the main memory, okay, through cache memory, okay. So this is already we know that this is a volatile memory. So this data will be loaded into the main memory by using the load and store instructions. Whenever it wants to take it from the hard disk to the main memory, it will perform the load and it will load it to the registers, and after calculations again it will store it into the main memory, okay. So this is the way it performs the interactions with the CPU, okay. The next secondary storage electronic disk or solid disk. It is also called as the flash memory. So for in cameras and all we are using that flash memory card only. So when we are taking photos, that the photos will be stored in the flash memory only. So after the storage is got filled, what we will do, we will we can insert that card into the system only. So we can store it in the system by removing that flash memory card only. Then we can store the photos into the system. Then again we can remove all the photos whatever we have saved into the system. We can delete everything. Then again we can put it into the camera. Again it will take it from the zero storage to the highest storage. So like that we are using the flash memory in the cameras. The next, hard disk. So this is the permanent storage in the systems, okay. So all the informations, all the instructions, whatever we are doing, that informations will be stored in the hard disk only. So when we are doing currently, that will be there in the main memory. So if we are when we are going to save, if you are typing any one documents and when we are not pressing save, then we are closing the system. Again we cannot go and see the particular data or informations if we are not saved in any name, okay. So because it will be there in the main memory, it won't go to the hard disk, okay. So it will be there in the main memory. This is the main memory. We will store whatever we are typing, it will be there in the main memory. When we are switch off the systems, it will be erased. It won't be go to the hard disk. So when we are typing, that time when we are pressing save, when you are giving save, then it will be brought into the hard disk. That whatever we have saved, it will be there in the hard disk. That is called as the secondary storage. So the remaining things will come under the secondary storage. The above will be called as the primary storage, okay. So the hard disk is main in the computer systems to store the data permanently, okay. So here how the hard disk will be. If we want to say, tell in the simple word, the hard disk will look like a idli cooker. So in idli cooker we know that one center one needle will be there. Then we will arrange all the plates above the one by one above another. So like that only the hard disk will also be arranged like that. One spindle will be there in the center. Then so n number of plates will be arranged. So each one is called as the disk, and the combination of and collection of disk will form the hard disk, and will be rigid metal or glass plates covered with a magnetic recording material, okay. This is the way the hard disk will be arranged, okay. So you imagine the idli cooker only, the same way the hard disk will be arranged, but it will be coated with the plastic cover. So the hard disk, it will be arranged like a idli cooker only. So we will see the single disk, how it will be there. This is a single disk. N number of disks will be there according to the storage capacity. They will mount one on the another, okay. So it is divided into tracks. The hard disk, each plates are divided into tracks. Again the tracks will be divided into sectors. This is called tracks and this is called the sector. Okay. So, why it is divided like this means we want to come to know where the data is located, in which sector, in which track the data is stored. To find out easily, it is divided into tracks and sectors. Okay. This storage and to store the data or to take the data from the disk will be handled by the disk controller. Already we saw how the controllers will be used to transfer the informations from one device to another device. Okay. So, this is the way the hard disk will be arranged. Okay. And optical disks, and optical disk, if you want to that is CD, compact disc. So, nowadays we are using the CDs only to see the movies, or if you want to install any software by using the CDs only, we are installing the particular software and all, we are using the optical discs. And magnetic tapes, it's like a cassettes. Previously used in tape recorder, we are used the cassettes. Okay, it will have some tape kind of thing, it will be closed with the glass cover. Okay. So, that is called as the magnetic tapes. So, when the head will be touching on that tape, then the sound will come from that. Whatever it is stored, the data will be read from that. Okay. So, that is called magnetic tapes. The next one is this is the way the storage devices are organized in the hierarchical way based on the cost, speed and the volatile of the particular device. Okay. So, next we are going to see about the direct memory access. What is that? Is simply it is called as the DMA. So, why we are using this DMA? We know that the CPU is there and input output devices also be there and disk will be there. So, whenever the input and output, because this input device or output device wants to perform the operations, we saw in the previous class only that organization only, and in timeline cycles, we saw how it will work. How the CPU and the IO devices will coordinate with each other, that we discussed. Okay. So, when the CPU is doing some work, for example, the process 1 is executing in the CPU, at the same time the input and output devices are, if we want to read the input from the user, otherwise we want to show the input to the output to the users, then what the input devices should generate the interrupt and inform to the CPU that I have ready with the data, or I want to send the data to the user. That information should give it to the CPU. Then the CPU will allow to proceed. Then it will perform the input operations or output operations. But if you want to transfer the bulk amount of informations, so this only 1 minute or 2 minutes interactions, it is okay, but continuously block of data it wants to transfer. For each block it cannot disturb the CPU. Large amount of data if you want to transfer, that time it don't want to disturb CPU time. Okay, because in these cases we are going for the direct memory access with the input devices or output devices won't ask the permission from the CPU. Directly it will go to the disk. That is, first it should go to the main memory. From the main memory it will go to the disk again. Okay, so directly it will contact with the main memory. That the main memory also having the limited storage only, so it should be transferred to the disk, because if all the information is storing it in the main memory, it doesn't have enough space in the main memory. Again, the CPU cannot execute other process. It will reduce the speed of the CPU, because the main memory is loaded with heavy information. If there is no enough space, then the CPU speed will be decreasing. So it should transfer to the main memory. Then then immediately it should be transferred to the disk also. Only one interrupt is generated per block rather than the one interrupt per byte. Okay, so for whenever it wants to transfer the this is the block 1, this is block 2, and this is block 3, like that. So instead of discussing for the each byte of data, it will communicate to the CPU for each block of data only. So if it wants to communicate for each byte of data, it wants to communicate for the 1000 times to disturb the CPU. To avoid that, for each block it will communicate to the CPU once, then it will directly transfer to the main memory without disturbing the CPU. So this is called as the direct memory access. So you see there also the device, from some secondary device we want to transfer the data to the main memory. Okay, so there we are not disturbing the CPU and we are not using the cache memory also. Okay, so directly we are transferring the data from the device to the device. Controller will handle this situations directly, it will transfer to the main memory. So this is the way the direct memory will occur in the system. Thank you students, we will see in the next class.